of event. Now I request our Honorable HOD, Dr. S.S. Kulkarni sir, to welcome the S.G. Kulkarni sir and also enlighten us on this occasion.
Good morning, everybody. Respected Principal Sir, Dr. K.J. Karande Sir of this institute, Vice Principal Sir, Dr. H.G. Kulkarni, and today's expert session chair, Tukaram, Honorable Tukaram Varak Sir,
Technical Director,
who is going to deliver the session on implementation of creativity and design thinking in project-based learning activity. As all of we know that from the first year itself now, university had changed the curriculum and they have implemented the curriculum syllabus of creativity and design thinking at first year level itself. So the students who will come to second year, third year, then they should try to implement their knowledge to the real life problems. Implementing your engineering knowledge to a real life problem is the main motto of this today's session. In the fourth year also, last semester is totally related to a project activity and which is carrying as per the university curriculum syllabus 200 marks are given. So student has to either implement the knowledge in terms of a project work as regular project work with audit course, and otherwise the students can go through as a sponsored projects also. From industry directly they can do the project work. But main theme is what? Taking a knowledge, getting a score is not important. Getting a merit in the university examination is also not important. But what is important to all the engineering student is to implement their knowledge to the project activity. So if you learn the project work, if you learn the project activity, implement your knowledge, then the creativity and design thinking is one of the important parameter try to understand, because traditional method was development of a project was only development of models were there. When we do the product development, do the model development, then we are joining the materials, different kinds of materials we are joining and we are producing a product, we are developing the product. But it is not so now. There should be certain innovation, there should be certain creativity in a product, which will be helpful to the society, which will be helpful to the industry, which will be helpful for, means as a real life problem, we should solve that. And every student nowadays, they have a thinking ability, they have a creativity, so that they can implement it in their real life problems. So for the today's session, I best wishes to all the students, and also on behalf of Department of Mechanical Engineering and SKN I welcome Honorable Tukaram Varak sir for this today's session. Thank you, sir.
Okay. Thank you, sir, and thank you to the principal of Sinhgad College, Pandharpur. I would thanks to the mechanical department and all giving an opportunity to interact with all these budding engineers or the future
Varak,
of
sir.
our. Yes, am I audible?
1 minute, 1 minute. We will introduce you and then you start your session.
Okay.
Good morning to all. It gives me immense pleasure to introduce today's eminent speaker, Mr. Tukaram Varak sir. Sir is working as a technical director. Sir has completed M.Tech from National Institute of Technology, Calicut. Sir worked with MNC like QST Global on CAE domain. Sir is a best trainer for ANSYS, CAE and engineering fundamentals. Sir has more than 15 years of experience in design and education domain. So such a great personality today we have with us. Today, sir, deliver a talk on implementation of creativity and design thinking in project-based learning. Now, I request to Dr. H.G. Kulkarni, sir, welcome our today's chief guest.
Thank you. Thank you, sir. Thank you, SS Kulkarni, sir, B.S. Gandhari, sir, R.K. Shinde, sir. So, it gives us immense pleasure today that Sri Tukaramji Warak, sir, is with us to guide us regarding implementation of creativity and design thinking in projects. Because from last 2 years, we are observing that due to this online mode, students are not able to create their projects on field visits or physical projects. So some kind of loss in terms of their practicals, their projects in physical mode that we have observed. But at the same time, we got the opportunity for the projects which are based on the modeling, which are based on the with the help of this, whatever the expertise of Warak sir is now available, that in CATIA, then ANSYS, then developing the models, and in that field, the students have grabbed different opportunities. At the same time, we have observed that in software industries as well as for the core industries, in terms of this online mode, new opportunities are came ahead. And with this, now students are coming for the physical mode. Institution Innovation Council is the initiative of Ministry of Education, and with that, the different guidelines are provided for the faculty members, for the students. The intention behind these guidelines are to improve the awareness in the field of creativity, design thinking, intellectual property right, entrepreneurships, startup developments, incubations, pre-incubations, like these activities that should get enhanced inside the institutes. And together, all these activities should get synchronized in order to develop the culture of creativity inside the institutes. And outcome of all that creative thinking, all these creative things in terms of many activities, in terms of projects, is to generate the new startups from the students. The main motto behind all these things is that the students learning in technical educations, the students which are having the background of science and technology, they should be job givers, but they should not be job seekers. So with that intention, this Institution Innovation Council has given the guidelines to all of us to create such a kind of environment. The things are same, but if that are done by different way, by different mode, with different skills, then that will generate new applications that will serve the society, that will complete the loopholes, whatever the present. Because socially or in industrial point of view, if we see the different applications are there are many times some loopholes findings are there, and to overcome on that, there are necessity of new projects. So this particular era, 2021 to 2030, that is considered for the innovations. Because nowadays with Industry 4 and next revolutions of the industries, now it is a requirement that innovations should be there. Sympathy, empathy, not only sympathy, but empathy is one of the important things through which the machines and mans are connected now with each other. So, with the requirements of the technology and with the requirement of this institution innovation councils, we are going ahead. So today we have eminent personality with us, experienced personality with us. So I once again welcome Tukaramji Warak sir for this session, and I request him for this session. Thank you, sir. Thank you very much.
Okay, thank you, sir. Should we start the session?
Yes, sir.
Okay, just a minute. Okay, thank you all. Thank you, Mechanical Department, SKN College, for giving me an opportunity to interact with all these budding engineers or the future of our country. Actually, we all belongs to the engineering fraternity, and we know that engineering is out there to serve for the society or serve for the whatever problems we face in a day, every day. So I would be giving the small introduction about myself. I have done the masters from NIT Calicut, and then I have worked with industry a few years, and then I came back to the academics recently, because that is the place where I find much interest. Okay, so today's topic is implementation of the creativity and design thinking in the project-based learning. So, quite interesting topic. And one more thing is that quite very much needful topic for today's scenario. Okay, if you look at the industrial scenario, if you look at the academic scenario, the learning, because of all these new normals where we are trying to adjust, the learning curve has somewhere missing. So to improve all these things, everywhere we find the new initiatives have been taken at the institution level, at the industry level, even at the society level. New initiatives have been taken so that this learning curve can be improved. So based on that, we'll start the today's this webinar. I will be getting 40-45 minutes to interact with all these young engineers. See, we engineering community, actually, as I told, we offer the product, or we basically work on the what is the pain area of the society. Okay, so actually pain area of the society or the industry, that pain area, we have the ability to convert that pain area into the some kind of solution we can offer on that. So actually understanding that particular pain area, like sir were mentioning the empathy, sympathy is not at all sufficient. We should have the empathy. Then and then only we can realize or we can feel what is the pain area of the society or pain area of a industry. So that pain area, we should be having the ability to take up that pain area as a challenge, and we can offer the product on that. So actually, see, curriculums are aligning with the project-based learning. That's what I understand when I interact with the different academic people. So this is the very good initiative as taken up by the universities, because whatever conventional learning process, actually it is necessary, but it is not sufficient enough to come up with a product or come up with a technical solution to the problem areas. So actually project based learning is already geared up on the developed countries, and their learning and their this problem solving ability is much ahead of us. But okay, we have taken the good initiative at the academic level, where student, faculties and industry engage together, and they can solve our own problem. So development, indigenous development is quite welcoming step for we all. So what is going to happen when we prefer the learning as a project based learning? So actually, when we expose to the any problem, we based on our observations, we try to understand what exactly problem is. So problem, challenge, or the problem, we can question it in a multiple ways, why it is, how it is, then a few more questions, technical questions we can ask that particular problem, or to that particular pain area of the society, and then we inquire thoroughly about that particular problem, and then whatever knowledge or whatever information we have, based on those standard information, based on whatever learning we have, we think of whether we can solve this problem or we cannot solve this problem. Means this is the very important step. That step is called as a feasibility step. So we understood the problem, but understanding of the problem in every aspect it is required. Okay, then and then only we can offer the product on that, or we can offer the solution on that. So once we understood the problem thoroughly in every aspect of that problem, and then based on our understanding, our knowledge, or whatever knowledge base available into the technical domain or engineering domain, based on that we can think of a solution of that particular problem. So whenever any candidate or any person is exposed to the problem, means it is the practical experiential learning or practical exposure to the problem, then understanding will be a very high. So based on that understanding and based on the technology available at our disposal, we can get an judgment whether we can solve this problem or we cannot solve this problem. So see, this decision is very important. Like if I say we want to come up with a bike and which should work on the water. Now this fuel scarcity and fuel affordability is the big challenge nowadays. Now this is the pain area of the society. We all exposed to that and we experience that. Now as a technical community, what we can offer, so somebody may think of we can come up with a product which should work on the water, but now technology is not available. Means I cannot solve the problem whatever options I am putting forth to this. So what option has come up? The electrical vehicle is the option has come up for the whatever pain area or whatever challenge before all these automotive companies and we as a user. So feasibility study is the very important, and feasibility study has to be done based on the what all the technology available. Now that authenticity of the technology, we need to test, we need to check that authenticity. So and then we can come to a conclusion that whether I should offer the solution or I cannot offer the solution. Once we decided that okay, we can take up this problem and we can certainly offer the technical solution to it, and then arranging the resources and getting things done. So what we require the manpower, we require the technology, we require the finances, we require the technical expertise, and all these things comes later once feasibility study is done. Okay, so actually whatever thoughts being taken up to come up with a product, if we inculcate to the students in this during their education itself, so that ability will be coming with the student. So if you look at the industry scenario or if you look at the academic scenario, actually what is being done when any candidate or any student enter into the industry and start the corporate career, actually he or she is not getting an opportunity to work on a project where from problem statement to offering the product. He or she will be working on a part of it, but some candidate is willing to start their own startups. In that case, that particular candidate will be going through the what all the steps I am talking about. Okay, so see if that culture is being encouraged at the institute level or colleges level, certainly it will nurture the talent, it will nurture the kind of willingness or kind of enthusiasm having with the candidates. So okay, so problem statement, then feasibility study, and then whatever technology available, arranging resources, and coming up with the product, and then final offering the product. All these processes, if any candidate is going through all these processes, the kind of learning will be achieved by that particular candidate, it much better than the those who are not taking up that kind of activities. Okay, so as a nation, as a country, we are expecting that more startup need to be come up in the our land, so that whatever indigenous problem we as a country facing, those problems can be solved at our level itself. We are somewhat dependent on the some products, import products, so there we can offer our own product. So that kind of culture, or if that kind of thought we give to this all the student, certainly it will be a good to a country,
Hello,
society.
sir.
Okay.
Sorry to interrupt you. The
Yes.
slides are not moving.
Okay, it is stuck.
Yes, yes. It is getting stuck.
Okay, so let me check. Please check now.
Yes, first. Yes, okay.
Okay, so that should be the goal of we all as a industry, as a academician, as a research institute. Our role is to nurture the this kind of culture at the institution level. So I would re-encourage the student to, when they are there at the society, they should identify what all the problems faced by the society. So most of the students belongs to the farmer community. We all exposed to the farming practices and all. We can identify n number of problems there, and even some of the student have that realized that particular problems. So we can take up that problem as a project. So project based learning, actually we get all the understanding about the problem in a bit greater depth. Okay, so actually in a project based learning, what all the advantages we get, each and every each individual is getting an opportunity to participate into the solution part of that particular pain area, and every student is getting the exposed to the problem through the exposure. The kind of learning it is getting based on the observation, a kind of learning it is getting to the student is very high. And actually when we come up with any product, we all collaborate together. The another thing we understand from this project based learning or collaborative learning, in that case we all the student collaborate together and they come up with a product. In that case, whatever individuality of the every candidate, so someone is expert in the management type of activity, someone is expert in the technology side, someone is expert with some another activity. Everyone's special ability will be taken care by this project based learning, because when we execute any project, just one part is not required, or there are multiple dimensions to it. As I told, there must be a technical aspect to it, there must be some social aspect to it, some resources management aspect, finance aspect. All these aspects will be taken into consideration when we develop any product. So each individual, if it is expert in the finance, their contribution will be there. So that's how that experiential learning or project based learning will be helping to the students. So actually a topic is implementation of the this design thinking and creativity for the project based learning. So see, what is the design thinking? That is the very important part to discuss. Design thinking means whatever problem to which we expose, immediately we should come and thought that come to thought that can I solve the problem, right? So that thought must come. See, every day we expose the multiple problems, multiple kind of challenges. So exposing to the challenges or reading the challenges is not sufficient. So once we expose to the problem, or somebody is suffering, or somebody is in a pain, so we should understand what is the exactly pain. So understanding is not sufficient. Beyond that, we should go the empathy. That is the main main understanding has to be there, so that once we realized what is the pain area, there we should start the our design process. So see, in the next step, see, empathy. Once we got the better and better understanding of that particular problem, and then we can define what exactly problem is. Now see, we all from the technical community, so understanding the problem is the one aspect, but the expression of that problem, we express the problem in terms of a physics. So understanding, since we are offering the technical solution to the problem, so technical solution or scientific solution, there are two important understandings are required. Okay, one understanding is the physics of the problem. Once we understood the physics in a greater depth, then that physics understanding is not sufficient. That physics has to be expressed in terms of a mathematics. So when we define our problem in terms of a mathematics, so we all are engineer, we understand the calculus is the tool we use to define our problem, or engineering problem statement is of the differential equations. Okay, so definition should come out with differential equations, and then once we define it, then we should think of the idea creation. So what all the ideas through which we can solve the problem. So if I take the one problem, that problem can be approached or solved in a different ways. So there are multiple ways to handle that particular problem. So each individual will be having the idea how that problem has to be solved. So collection of the idea, it is the another step, because I may not be able to offer the solution, but someone is in my team, is quite good at that particular area, he can offer the better idea. So multiple ideas we can get for the solution of the single problem. Like transport, if I want to travel from one location to another location, what all the ways available? We can go by walk, we can go by bicycle, we can go by the motorcycle, we can go by the car. So multiple ways are there to reach out there. So likewise, if you take the any problem, if you have the any problem, we can solve it in the multiple ways. But again, every idea, whatever we got, that is has to be assessed it. So what is the assessment criteria? And taking up the one idea picked from the bunch of ideas those have come up on our table to solve that problem. So multiple ideas, one idea is selected based on the feasibility of the idea. So what all the feasibility checks we are doing? One, feasibility, whether technology is available to realize that idea into the real product. Okay, that is the very important part. Otherwise we cannot realize our product. Whether I have the technology available with me so that I can use that particular technology and I can realize my product. So one feasibility criteria is technology availability, or whatever the technical expertise required for that realization of idea, whether it is available or not. Then another thing, whatever problem I have identified and I am trying to offer the solution, that group or the beneficiary or the customer, I should keep into mind about that targeted group. Because if I am offering the solution to them, and if that is not at all affordable to them, then even though we are giving the technologically fine solution, a best solution, but it is not being affordable to the targeted group, means again we cannot take up that idea. So see that financial aspect has to be considered, whether it is financially viable product or it is not. That also one criteria through which we pick up the right idea for the further realization of the products. So see, and few more factors are there, but these two are very important. Whether technology is available, if technology is available, I can come up with the product. Certainly, another aspect is the commercial aspect. In a commercial aspect, we are keeping our targeted group in front, and we are discussing the prices and all. So see, based on that, I will take the idea for the further realization of the product. So based on multiple ideas, once I chose this idea is the most feasible idea, and I can realize the product and I can offer this product to the targeted group. The next step, it is the prototyping. So that is the one more important area. We will we will be doing the prototype of whatever solution we have worked out, right? So prototype, once we do the prototype, then actually we send it for the testing, and once we test it, so see, one more thing is that whatever product we idealize, we come up with a prototype, we tested it. In a first state itself, we cannot pass the product because we don't have that level of understanding where in a one go my design is a fine. No one is there actually. No one is there. So multiple iterations are required so that finally we can fine tune the products. So when I come down to the mechanical engineering, so whatever product we offer, so whatever we have the understanding of the problem, based on we come up with the product, and see, still we are not sure that all possible users behavior or how user is going to use that product, all uncertainties are not considered. It is not at all possible. Once we release the product, how user is going to use, we are not aware. But still, as a designer, what is our priority? Our priority, that product should survive, that product should give the performance for which we designed, or you should fulfill the need of the whatever targeted group for which we have come up with the product. Now, but see how that is mitigated. One thing is that we are not totally sure about that how product will be used by the end user, and another thing is that see my intention is that should perform well, or it should fulfill the need of the end user. So how it is done? So basically, what we give the some buffer to my design. Like if I say take the example of a bike, the bike actually when it is designed, two-wheeler bike, it is designed for the two person sitting on that. Okay, so that is the design. If I design for only sitting the two person, and see third one is sitting on that, and if it fails, so it will be blamed to the company or it will be blamed to the designer, right? So what we do, even though a third person is sitting, even though there is some excess weight is applied on that, it should survive. That is a well taken care into the development stage itself. So when it is taken means through it is the factor of safety. Whatever factor of safety we consider, the factor of safety is there with the design to make product survive even though in some uncertain conditions, right? So testing phase is the very important phase where we try to assess the performance of the product. We try to assess the life of the product. If at all it is going to fail, how it will be failing when we put into the service. It is being tried, it is being tested into the development stage itself. See, I have a product I developed, I got the final product out from the factory and I put into the customer's hand. And see, if that particular product failed into the customer's hand, it is not properly working, or whatever need we are trying to target, if it is not fulfilled by that product, then complaints or the customer queries will start coming up. So in that case, we as a manufacturer or we as an engineer, whatever product we offer and continuously it is being not serving the purpose, in that case discontent from the customer would come. So see, we don't have the chance to correct it because already we have released the product. It is in the user's hand and user started getting the problems. So see, in that case, what will happen? A reputation of the company will be lost. So testing is the very, very important activity where we test the performance, we test the life, how it is going to fail. So this is the thought process has to be applied. So you all young engineers, and every year you have the projects, that's what I understand. So see, one part of the project is the technical part, along with there are multiple thoughts are required so that every dimension of the product will be considered, and that will be giving us the better performance. So what is being practiced now for the academic project? Only technical focus we give. It should not be only technical focus. You all young engineers, when come out and roam into the society, you will identify n number of problems, especially rural part of the India, some farmer community, some laborer community, they have their pain areas. And see, when I was working with some another institute, I encourage the student to go out into the society. You go out into the specific domains and identify their problem, come with that problem, and then define what exactly problem is there and how you will target it as the solution. And some of the student really they come up with a problem, really they thought of offering the solution, and some prototyping they did it, testing and all not possible because they had a limited time and all. But again, see, you guys are having the enough time. Small problem I would encourage to take up and think of how to solve those problems technically. See, technological solution we have to offer it because we are from the scientific background. So if you take up, see, medical, there are so many pain areas. As I told, the laborer, they have their own pain area. How to lessen their pain areas or reduce their pain area, that must be the target. Okay, that's the reason first word is the empathize, means we must understand or we must feel their pain area. Once you felt that, then see, whatever product you will be coming out, that will be the best product, it is assured, right? So see, just understanding is not sufficient. And see, these are the stages. It is being iterated again and again till we get the fine-tuned the product. So see, every aspect we considered with our product. So for every aspect we have to test it. Whatever comes into my mind, whether it will work in this way or that way, or if it is at all it is failing, it will fail in this way or that way. Whatever thoughts comes with my mind, based on my knowledge, based on my domain expertise, based on my understanding, everything has to be tested in the development stage itself. This is a very, very, very important part, because once we release the product, hardly we will get chance to do correct, because we'll lose the market, right? So these are the steps through which any design process goes. Either it is the mechanical engineering or non-engineering projects also offered, or it goes through whatever stages here listed on the slide. Okay, so hope you all have understood. I would encourage you all students, when you roam into the society, go anywhere into the society, whenever you expose to the problem, try to understand that particular problem in a greater depth, and once you back from that particular exposure of the problem, then try to define that problem, because for engineering problem we need to have the clear cut definition. Okay, so vague definition is not required, because until and unless clearly we define the problem, we are not going to offer the solution. So define the problem, then you think of how it would be solved. A solution is based on whatever you are learning, whatever understanding of the technical that you can invite there, and you can come up with the idea. That idea you can discuss with your friends, your faculties, your some peers, and you get the validation to that idea. Then you refer some standard resources like journals are there, standard documents out there into the public. Tap those standard documents and validate your idea. Idea validation is the very important, because success of your product lies with the idea validation. Okay, and then you start realizing the product with the whatever resources at with you. You try to develop the prototype it, and then you test it. Now one more important thing I would like to share or discuss here. Earlier, whatever prototype I would be coming up, it has to be physically tested, and testing of the that physically, it require so many resources, means lab facility has to be there, then that expertise has to be there. Along with that, some financial also we need to handle in that case. But recently, whatever virtual tools out there into the practice, you will find all those virtual tools are widely and extensively used in the industry or academics, even a research institute. All these virtual tools are there at the every college level. You can make use of all those virtual tools, and you can test your product just sitting on the your computer. That's it. Okay, so whatever modeling softwares are there, whatever CAE softwares are there, even some manufacturing related, this 3D printing and all. So these are the options available us, where we can save the money and we can save the time, because we work with a limited time span. In academic, you will be having the deadline of the 4-5 months. Within that, you have to do all these things. Means if you go for the actual testing and all, it will take a longer time, and you need to bear the financial burden as well. So whenever all this prototyping is at all, we can test it on the computer with the virtual tools. You can check all possibility of the your product. That is the big advantage offered by the virtual testing. And if you look at into the industry as well, the virtual testing has gone up like anything. The reason being, if you look at the product life, if I say the mobile, if you buy the mobile today, we think of changing the mobile in the next few months. So within the few months, as a company or as a manufacturer, I have to come up with a new product, and that product should be a technologically well tested, and that must be having the some additional feature. Okay, then and then only I will survive into the market, otherwise I will be out of the market. So companies are having the very limited time for the development stage. If they select the only testing and all, they will not be able to launch the product on time. Okay, in that case, the virtual testing is possible. So I would encourage you all students, whatever testing facility available at your college level, you use all these virtual testing facility. Along with, if it is the testing, actual experimental testing is possible, then you can go ahead. But most focus has to be given on the virtual, because I am telling, because one thing is that the time, and another thing is that cost. But again, virtual testing is so far as is not accepted by the industry or academic, because that has to be supported by the experimental approach. But just once a base model, if you come up with a base model of your project, and that base model got validated with the experimental data and the this virtual testing, then further iterations with your project you can do only virtually. That's what being practiced into the industry. If I want to test the different materials, if I want to test the different shape, if I want to test the different sizes, so what creativity is whatever conventional ways through which we are solving the problem, we are going out of that and we are trying to handle the problem in some another way, right? Where what is our target? What is the, we are trying to bring the easiness to the user, right? Kind of comfort we are offering to the user, that we can offer through different creativities and all. So if you look at the whatever transport vehicles are out there into the market, from the bicycle to the aircraft, and every automotive sector also you will find the different variants. Some variants will be giving the better and better comfort to it. How come it is possible for those companies to offer that kind of comfort? Because all possible engineering, all possible ideas, all possible domain expertise, they invited it, and based on that, all most of the uncertainties that can come when we release the product into the market, understood into the development stage, and they tested it and they got the technological data, and based on that they have fine-tuned the product. So iteration is the main important part of the any design. It keeps on iterating based on the feedback. See, we are offering the real life product. So real life product means actually the physical product will be there. See, same thought process we can implement for coming up with some service. Okay, so service is actually how service model is tested. It will be released for the some group of people. Feedback would be taken, and again it will be fine tuned, and it keeps on refining, keeps on refining the same way. But whenever we firstly release it, it should be at a certain level, and then further some correction. See, we cannot offer the perfect product. There would be the some improvement chances, whatever it may be the product. I am sure about this. So further see, iterations or further improvements are quite possible, but at least the product has to be at a certain level. So see, you use this thought process for your academic projects, whatever project are given to you, or whatever project you are doing at the academic setting. So you take the real life product, you real life problems, you take the problem of your choice where you have the better understanding, and try to realize it. And later see, if your idea is genuine, if you have the genuine solution to it, is there, see, funding and all later, it is not a big deal nowadays. Everything is available. Thing is that idea should be a very feasible, and really it should target the market, it should target the pain area of the society. So again I am telling, so you identify the problem. N number of problems are there. See, whatever products we use, the most of the products are those are developed somewhere else. It is not indigenously developed. When it is indigenous, see, our problem is different than the problems of some another region or some another geography. So indigenous development has to be encouraged, so that we can identify the problem there itself. We have the greater understanding of the problem, then we will be having the greater product for that. So whatever product we use, it is a generalized somewhere else, generalized requirement, and they are trying to solve that. Okay, so these are the steps in the design thinking, and it has to be implemented for your academic project. Might be a small project, might be a small problem, but you go through all these thought processes, you follow these steps, then certainly you will qualify just like an entrepreneur. You will be competent enough to start your own startup and all. And see, kind of ecosystem is being developed from the institution level or government policies. that ecosystem is out there to encourage the startups. Like sir said, we should be a job givers, we should not be a job seekers, and that ability we all have. Even if you go into the industry, even industry actually allows you to work on a certain part of the project. You won't get an opportunity to go through all these steps. But when you start your own startups, when you start your own venture, in that case you have to go through this, right? So this is the design thinking, and you can perfectly implement for your project. Again, I am telling, identify the problem. That should be the indigenous problem. You have the resources around you, make use of those resources and try to solve that problem. It will be a big giving back to the society. Okay, and we all have that ability. Only thing is that we have to think beyond whatever mindset is having with all us, right? So hope you all have understood this. So these are the basic steps. Creativity means doing something which will be offering the easiness. Creativity means it is not just like we are developing something hypothetical. Okay, see, we deal with the real life products. We are really handling the problem. So see, whatever picture shown here, so whatever solutions are there, it is beyond conventional solutions. So creativity, it is there with everyone, it is there with each individual. You just come with that solution. So see, first figure, if I want to push all this, the circular object is quite easy to see. Here some another, so you think it. So see what is there, what is our mindset, or what is it is deep rooted in our mind, whatever we expose to it. The television has to be the square, chair should be in this way, whatever products around us, based on the exposure we are fed up with, only these are the options. No, beyond that there are multiple options. So whatever comes into your mind, you try to implement in your project, and you test it, because see, immediately you are not going to commercialize your idea, right? It takes a very long time. So whatever whatever creativity comes into your mind, it may be a great creativity you can incorporate in your project, and really it will be solving the problem or making your product to more viable. So all the creativities, those are, it cannot be taught. Creativity cannot be taught, it has to be coming within each individuals. So you have an opportunity to implement what creativity comes into your mind, or it comes into your thought. So you put for your project and make the project something worth project. So see, every project or every product will be having the two aspect. One is the engineering aspect, another is a non-engineering aspect. Engineering aspect, it is more close to the performance and the life. Okay, and another is the aesthetic approach, non-engineering, that what should be the color, what should be the shape, all these factors. Again, if you come up with a creativity and implement with your product, again sellability of the product will be a very high. So along with engineering, non-engineering parameters, if you think of and integrate with your project, certainly project will be more attractive. Okay, so actually from this, if you start thinking of this, whatever thought I am trying to convince you, certainly after a couple of years you will be competent enough to start your own startup. Okay, and really you will be getting the kind of satisfaction, because you are solving the problem of the society, you are giving back to the society. One part is the commercial, leave it, but another part is the real tackling the society problem. And technology has that kind of power, technology has that kind of ability to solve the problem. See, life 100 years back and life current life, there are so many a lot of change. See difference. Okay, what is the this difference driver? A driver is the technology. Driver is the technology. So technology or technical technocrats are having that ability to make the difference into the society. Every product, whatever products we use in a day, that is the product. Their engineering has done. So think in this way so that your project activity will be a worth activity. It is not a sake of completion. What I understand when I interact with some student through the recruitment process and all, what understand when any company is recruiting the freshers, what they look for whether that project, whatever academic project, whether he or she has genuinely completed the project or just a sake of completion. Those who have genuinely executed that, certainly a preference goes to that, because project is the activity or it is the important part of your curriculum where you get an opportunity to implement what all things you have learned in your academics. So that is the place where it can be tested. That's the reason industry, when any candidate is being recruited, they are show the keen interest into the project, right? That's what my experience is. So you can implement the design thinking, along with you can invite the creativity what comes into your mind. And you all guys are fortunate because you all guys have the virtual tools with you to test it. The whatever comes into your mind, you can open your laptop, your PC, there are the tools, and you can realize virtually there and you can solve it. That is the best options available with you. Okay, so see, in a mechanical design, what is the thing we are doing? See CAD, CAE, CAM, all these are the important implementation stages. See, CAD is helping us to do the things. CAE is also helping us to test the product, and CAM is also helping us to come up with the product. But these are the helping us. They are not making us the designer. They are not. Idea should be come into the mind. That's the reason. Whatever topic of the today's this webinar, it is the design thinking. Later, these are the helping hands. They are not making us the designer. They are helping us to lessen our efforts, or quickly we can get the some result, or whatever idea testing. It is possible because of all virtual testing. See, one thing is that whatever benchmarking and all these things are required for the any design, but it is at the college level and all, actually idea testing, that is the very important. See, you all will be having the a fantastic idea about the solution of the any problem. You can take up that idea and you can test it. Let it be, it is not worth or it is worth idea, leave it. But whatever idea comes into your mind, you use all these virtual tools, you test it, and you conclude it. It is the feasible. These are the reasons. This is not at all feasible. These are the reasons. So that is the learning you will be getting through this project activity. So again, I would encourage you all young engineers, students, dear student, try to identify the problem. That should be a genuine problem. Try to feel that problem, then define that problem, then come up with the idea, validate that idea, and then start realizing it through the virtual testing and all. Again, if you have the time, experimental is always preferred way to test the product, but time and cost, these are the two challenges before. Even it is not before the student, even it is before the student, research institute, everywhere. These are the big challenges. So since this new option is available with us to test any product virtually, you can test it and you can improve your learning. you would get the kind of satisfaction when you handle the problem, which is really making some easiness to the user. Kind of satisfaction you will be getting, you cannot measure in terms of some another means. Okay, so see, whatever I discuss in this webinar, try to implement in your project. Let it be a small project, big project, but idea should be indigenous. Okay, so problem should be a R reason problem. Then whatever problems being faced by the every sector of the Indian community, we all engineer can tackle this. Why they should be dependent on the product those are coming from the some another countries? We have that talent, we have that will, we have that creativity, everything is there, only ecosystem, and that is also being established. So I am very happy by listening from the sir that the incubation, so many things are geared up to develop this kind of ecosystem where student can offer the job, not seek the job. They can come up with their own startup, right? So this things I have discussed in this webinar. Now floor is open to questions.
I request to student participants, if you have any question, please ask. If you have any doubt or any question in mind regarding this session, please ask.
See, our organization is quite open to support the any idea. We have the lot of resources around us. We can help you in every aspect of your project implementation.
Okay. I Professor R.K. Shinde from Mechanical Engineering Department, vote of thanks. To thank today's chief guest, Mr. Tukaram Warak sir, for a very nice, informative and interactive session on implementation of creativity and design thinking in project-based learning. During the session, sir nicely explained all the aspects of project-based learning and design thinking. Sir, definitely your session is helpful to our students. I would like to thank Honorable Principal Dr. K.J. Karande sir and Vice Principal Dr. H.G. Kulkarni sir for always motivation and guidance to organize such sessions. I would like to thank Dr. S.S. Kulkarni sir, Head of Mechanical Engineering Department, for organization of this session. I would like to thank all the coordinators and members of Institute Innovation Cell for all kind of support. I would like to thank Professor H.S. Deshpande sir, coordinator of this webinar series, and all team members for nice organization and successful organization of this webinar series. I would like to thank all teaching and non-teaching staff members for all kind of support. Also, I would like to thank all the student participants for their active participation. Once again, I would like to thank one and all present here, and with the permission of chair, I declare that this webinar series is over. Thank you very much.
Okay, thank you all.